So in the last video, we learned how to convert any three-dimensional point anywhere out in space, put it onto a projected two-dimensional plane. And so now what we're going to do is take a list of coordinates that corresponds to a two-dimensional plane and then convert them onto the two-dimensional projected screen. So that in the future we can do some cool equations and fun stuff like that. But we need a plane to start out with, so that's what we're going to program today. This is the two-dimensional plane that we'll be creating. You can tell that it has some length and some width to it and no height on it. And so those are the initial coordinates that we're going to have to program into the 3D vectors. Okay, and to start off with, let's bring the tkinter and math libraries in again. And here's the 3D to 2D convert function that we made last video, but we're going to make a couple of modifications to it just to make it nicer. First, just get rid of this size. Instead, put on this XP 1920, and on the YP put 1080. Again, those are the coordinates of my screen size, so you can use different coordinates for whatever screen size you have. Also, let's get rid of this tangent of theta part. Okay, we should be good with the convert function for right now. Now let's say that we want to have a length on this plane of, let's say, 100 points. So let's say length is equal to 100 for right now. And now I'm going to set up an empty vector right now called chords. This is going to hold all of our three-dimensional data for all of our points. Now we need to write two for loops, one to go along the x-axis, and then for every single point on the x, we need to make another row on the y, so we make a bunch of rows and length of 100 by 100. So you can run this really quick if you want to see that your first for loop will go from 0 to 100. That's why I put the +1 in there. Now just make another empty vector called add. And then now we need to put our second for loop inside of this first for loop. Now say the add.append, and inside of this append we need to even fill another vector. And in this vector put I, j, 0. So now as this first for loop goes up by one level, we'll be filling in all these i's, and then for every single I, we're going to have all the combinations of all the j's along each row. And then we'll move up another I, fill in all of the j's, and move up another I, and then fill in all the j's once again. And then since we want it to be a flat plane, just put 0 for the z coordinate or whatever other coordinate you want to use, so that it's just has no height to it. Now once you make the add vector and the second for loop, that's like the equivalent of saying you get every single row done. So then you can append all of the coordinates by add every single time so that you're putting a new row in every iteration of the I loop. Okay, go ahead and copy the two for loops from above and then get rid of that little add line. So these two for loops basically go through and access every single point along the coordinates. So we could say that in coordinates of I, j, like the position I, j, we can get the 3D coordinates, which are located all the way inside there. What I mean by that is like x, y, z are in coordinates like I, j. So if we have those x, y, and z values, those are what we need for our convert function. So let's say that x projected and y projected is equal to convert. And now all we need to put in there is our coordinates of I, j, and then our observer position. And we don't have an observer position, but let's put it at like 20 and 20 and maybe minus like 50, so it could just be, far out of the picture for right now. Make sure you put brackets around it so that it knows that it's a vector. Okay, let's go back up to the top and put in our just tkinter, how to open up the canvas on the window. Okay, so all this stuff right here just makes the tkinter window, then puts a canvas on it with size. This time I'm going to use 1920 by 1080 again to be the size of my screen. And then now we can use this canvas to draw stuff like circles on it. I guess one other thing, before we continue any further, we don't have a tangent of theta anymore, so let's create something that's called like a global variable. Global variables are variables that you can use anywhere in your functions that can be created outside of your functions. So normally you have variables that just exist in your function and they don't really come out of it, but if you put a global variable in the main part of the program, you can use it in different functions and you can just use it all over the place, sort of. Okay, so I'm going to use the same field of view angle as last time, but now we need to just say the line global TOT, and now we can say the tangent of theta is tangent of theta. So even though we have this TOT all the way out here, we can actually use it inside of our convert function without even using it as an argument or anything, so it's kind of cool. Okay, so now underneath this observer, let's say that the same thing, like oval equals 5 for our thickness of our circles. And then put the graph.create_oval, same exact function as we did last time. So we have the 2 points on the oval as like xp and yp minus oval and xp and yp plus oval. And then let's make it green colored. Now that I'm thinking, I think that 100 points is going to be way too many for us to render, because it's not just 100 points, it's 100 times 100, and Tkinter is not meant for this at all. So let's just put it down to like 20 by 20 for right now. We'll see how that does. So I changed this length variable from 100 to 20. Now go all the way back up to the top and type import keyboard. And right above these for loops that are at the very bottom, put while true. What you can do to indent and dedent is highlight your whole thing and then press Control left bracket and right bracket to indent and dedent. And then let's use the same keyboard commands as last time. So like the arrow keys control the X and Y coordinates, and then W and S control how far in and out of the screen you're going, like for the Z. And since they use the variable speed, let's say speed is equal to like 0.2. I think that'll be fast enough for right now. And then under all those keyboard commands, put root.update and then graph delete all. Okay, this code is now ready to run, and let's see what we get. Okay, so we can fly around in this. That's good. You can tell it gets like distorted as you get really close. So that's also good. The only issue is that it's in the X and Y and we put Z as 0. So instead of that, let's make it so that it goes by X and then Z and then Y is 0. So we can actually like look at the plane like kind of from the side and then look down on it. All you do is basically make this Y just zeros, and then where the Z's are being put in, put J. So our spawn in point is a little bit low, but that's fine, that's just where we put it. And this looks exactly what I'm trying to show you guys how to do. So we can start putting partial differential equations and solving multiple variable equations, all kinds of cool sort of simulation and all kinds of really cool stuff. But we need this basis in order to do that. And I'm just curious, so let's see what happens if we put 100 by 100 points. So we're going to change this length from 20 to 100. Yeah, very, very slow. Once we're done with this stuff, hopefully I can show you guys how to do GPU rendering. Lots of different GPU techniques make this way, way faster and way better. So I hope you guys like this, and you can kind of see what my past videos were kind of leading up towards, solving equations, and I show you guys different ways to solve equations. I showed you guys like what the wave equation kind of is, so we could put like, different partial differential equations on, now we can have like a better platform to actually, show what's going on, and to do them in higher dimensions, which is really cool and really fun. That's going to be it for this video, so thanks for watching.